welcome to It's Easy. In this series, I am covering basics of electrical engineering. Previously, I discussed about series and parallel connections. In this video, I want to move further. So, without a further ado, let's get started. In part 4, I will discuss about voltage and current divider rule. These rules are used to determine voltage and current in a simple circuit. The first term is voltage divider rule. What is it? It is just a basic rule which is used to determine the voltages across resistors when they are connected in series. Also, do remember voltage always remains same in parallel. What I mean from this statement? It is that the voltage will remain same across all resistors when they are connected in parallel. Okay, let's understand it through animation. Say there are 3 resistors connected in parallel. There is 25 volt source attached with the circuit. Every point on red line is at same voltage, which is 25 volt, because there is no resistor in between to drop the voltage. And every point on green line is at 0 volt, or you can say at ground. As you can see from the diagram, every resistor has 25 volts across, which means that the voltage remains same when resistors are connected in parallel. Continuing voltage divider rule. When resistors are in series, the voltage divides across them. Suppose there are 3 resistors connected in series. There is 25 volt source powering the circuit. Let's first look at the formula used for voltage divider rule. According to this formula, if you want to calculate voltage across any resistor, then to calculate it, you have to divide value of that particular resistor with value of all resistors added and then multiply it with the total voltage, which is 25 volts here. To calculate voltage across first 50 ohm resistor, we divide 50 ohm, which is resistor value, with the 200, which is total resistance added, and multiply with total voltages. It yields 6.25 volts. Similarly, you can also calculate voltages across other 2 resistors. Do note that the voltage across 100 ohm resistor is large because of Ohm's law expression, where voltage is proportional to resistor. Second term is current divider rule, and do remember that the current remains same in series. To understand it better, let's suppose there are 3 resistors in series. There is also a 25 volt source connected with the circuit. So, to calculate the current in series circuit, use the formula in which divide total voltages in circuit with the value of total resistance connected in series. In this case, divide 25, which is total voltages, with the 200, which is total resistance, and it yields 0.125 amperes of current. Now, what is current divider rule? It is a rule which is used in circuit analysis to calculate current division when resistors are connected in parallel. Yes, current divides in parallel. Again, to understand it nicely, let's use an example here. Suppose there is a circuit with 3 resistors in parallel and 25 volt source. As I explained earlier, there are 25 volts on red line and 0 volts on green line. Before using proper formula of current divider rule, let's use basic concepts that we have learned so far in this course. Here, as we know voltages across every resistor, and we also know the value of every resistor, then we could simply use Ohm's law to calculate the current across every resistor. Across the first resistor, simply divide 25, which is voltage, with 50, which is the resistance, and we get 0.5 ampere of current. Similarly, current across other resistor can also be found. Before moving on, a little reminder: if you are enjoying this video, then sub to the channel would be very appreciative. Moving on, let's discuss current divider rule with proper formula. Suppose there is a network of 2 resistors connected in parallel. There is a total of 10 ampere current is entering a network. The formula for 2 resistor network circuit is this: To calculate the current across any resistor, divide the value of opposite side resistor with total resistance of connected resistors in parallel and then multiply it with the total current entering the network. To find it across 50 ohm resistor, divide 100, which is value of opposite resistor, with 150, which is total resistance, and multiply it with 10, which is total current. The answer here is 6.667 amperes. Similarly, the current across 100 ohms is calculated. In this case, notice that the current across 50 ohm is more than across 100 ohm because of less resistance. Let's now add one more resistor. The current coming in the network is same, which is 10 ampere. The formula for more than two resistors is different. The formula for this case is displayed on screen here. Let's have a look upon calculation to have a better understanding. Across 50 ohms, after writing the required values, it yields 4 amperes of current. You can also measure current across other two resistors as well using the same formula. I hope all of you found this video helpful. If yes, then consider liking and subscribing. It gives motivation to improve the content. I will be back with next video, but till then, bye.